In this video, we're going to continue our discussion of stack buffer overflows, and we're going to walk through an example. So here I have a very simple program. I have my main method, which takes input on the command line. I define a local variable called local string. I define a local integer variable, and then I call function with the first parameter passed in on the command line, which the user controls. And that means that it could possibly overflow my string. So here in function, I take that same string and I also create a couple of local variables, including local string 2, which I give a length of 10. A length of 10 for a string means that that string can at most have 9 characters because I need a space for the terminating null character. I call stir copy and I try to push that parameter into local string 2. Hopefully it will fit and not overflow. And then I return the value 1 from my function. So that's a pretty basic program. Now, we have the source code for this program, but I wanted to show you a really quick example. How could you cause this program to crash? Maybe you didn't have the source code, so you just want to test it. So what I have is a very simple Python script that will call my program, which I've compiled. I called it buff. It will call it and pass it some parameters, and I'm going to use those parameters in order to figure out just exactly how long of a string I need to pass in. So in the previous video, we talked about wanting to overwrite the return address and then give it some shellcode. So we have to know exactly where to write that address. And it's going to depend on local variables and such, exactly where that falls. So here in my Python script, I call import subprocess. Subprocess is a module in Python that allows me to run other things. I have a variable called param, and I set it equal to the string of buff plus a space. And then I call this little loop. So in my loop, I say for I in the range A1 FF. What this does is it gives me values for I from A1 hex to FE hex. Now you might say, Phil, I think you got that wrong. It should be FF. One thing you'll learn about Python ranges is that the last value is not inclusive. It's up to 1 minus that value. So in my for loop, I add the character who has the ASCII value of A1, A2, etc. to my string. And then I call my program using subprocess call right here, and I pass that string in. What this will do for me is when my program crashes, it will allow me to see where it crashed. And that can be an important thing to know. So let me go ahead and go to my command prompt here. Now to run this program, I need to run Python. So Python I have in another directory. So I'm going to give it a full path. I'm going to say python test.py. It's going to run my program, and notice it instantly crashed. And it says, if you click here, I will give you more information. And what you see is this offset. This is the piece of information that you want. It says, I tried to access this memory location D0CFCECD. Now, recall from some previous videos, we talked about endedness. And we said that on the Intel platform, numbers are stored in little endend format, which means the smallest byte comes first, etc. So when you see an address like this, it tells you that in memory, it saw CD, CE, CF, D0. So in other words, this started at CD. So now we have a starting point. So how far into our string was this? I can go ahead and click on Don't Send the Report because nobody cares. I can either use the calculator built into Windows, or I can use the calculator from Linux. Either one will work to get the information that I want. So I'm going to go ahead and run the Linux calculator. Go ahead and run this in programming mode. So I have the value CD, and from that, I want to subtract my starting point, which was A1. And that value is equal to 2C. So what is that value in decimal? Well, right here, you'll see that it displays the value is 44. So 2C is equal to 44 in decimal. So what that's told me is that I need to go out 44 bytes and then input my desired address.